folks, today we're going to take a look at practice project number 2.2. This is taking the material that we've already created in practice project 2.1 and creating a Gantt chart with it. You'll notice that in our network diagram, I've added start and stop nodes that are common. In other words, they're the same shape. They are not the same shape as your actual project, and this is a common way for us to differentiate that the start and stop is actually telling you where the boundaries of your project are. I've also indicated the critical path using a red arrow and red blocks as we go through the system. We've also changed the ID number to match what we need for the Gantt charts. So instead of A, B, C, D, it's now 10, 20, 30, 40, so on and so forth. The start node starts with 10 and then 20, 30, 40, so on until we get to the end, which is 100. And while we ID the start and stop nodes, they're not actually part of the network diagram. So now we're going to take each of these numbers, right, and we'll just simply say 20, 30, 40, 50, 60, 70, all the way down. Then I have already assigned each of the task and names for you to make this process a little bit easier. Our next step is to simply take the predecessors and we'll add those in. So the predecessor to the defining requirements is going to be the start node. So we'll come here and we'll type in the number 10. Right? Predecessor for assigned team is defining requirements. That's ID number 20. So we'll type that in. For designing hardware, we also have to define the requirements first. So that's going to be number 20 as well. For coding the software, we're going to come in and here, coding the software, we have to assign the team first. So coding software will have predecessor number 30. When we build and test the hardware, ID number 60 has predecessor ID number 40. We have to design the hardware before we can build and test. Developing the patent requirement can happen at any time, so that has predecessor number 20. Testing the software, we have to code before we can test, so ID number 80 will have predecessor ID number 50. So we come here, we simply type in 50. When we integrate the software, we now have a merge activity. So we have ID number 60, 70, and 80 that we have to put in. And we'll put them in that sequence. 60, 70, and 80. So we type 60, move over to the next block, type 70, next block, 80. And finally, my finish or my stop node has integrate system. So we'll type in number 90 here. Okay. Now what that does for me is it started to put in and added these dots into my Gantt chart. As we put in our time elements, those will start to fill out for us. Now we want to add the time. How long do we think it's going to take us? So in the most likely scenario, this is where we're going to put the duration for each of them. This is where we'll put the duration for each of them. So the most likely for the start is we're going to put 0. That's not going to take any time to get started, so we put a 0 there. Defining requirements, the duration is in the orange block in the middle, and so we simply put in a 10. For assigning team, we put in a 5. Designing the hardware takes 25 days. Coding takes 20. Building and testing hardware is going to take 50 days. Developing the patent request, 15 days. Testing the software, 35 days. And integrating the system, 15 days. And finally, at the bottom, we leave that alone. Right? If we put in 0, then it will mess things up. So we'll just leave that alone for now. Now that is most likely. This is what we assume is going to happen. Okay? We're now going to take the optimistic, which is the minimum task required, and this is assuming that everything is going to proceed faster than normal, and the pessimistic, assuming everything is going to be slower than normal. So for this, we're simply going to take the middle number and subtract 2 from it, and the middle number and add 2. But for my start node, because there's no time there, I simply put in a 0. Here, I'm going to say equals the middle minus 2. Now, 2 is not the normal, and 2 is not the most likely. We're simply saying that if all goes well, we should be able to shave 2 days off the time for that. And then we simply autofill all the way down. For the pessimistic number, we come here and we say, okay, that's going to equal an extra 2 days, so we're going to add 2 days to that. And we autofill. All right? Now, what we end up with in the middle is the most likely scenario where we think this is the best that's going to happen. And once we're done, we can now match the numbers for the early start, early finish, late start, late finish, and slack. You'll notice that the expected time is exactly the same as the most likely, and that's because the O and the P on each side are even. In other words, it's plus or minus 2 days. Now, if you hover over the duration time, it will show you that there is a formula that is used. This is called the triangular distribution. Okay, the first one is called the beta distribution, where you take 0, or the optimistic time, plus 4 of the most likely, plus the pessimistic time, and you divide by 6. The triangular distribution is simply O plus P plus M divided by 3. So in the triangular distribution, it's just an average, whereas the beta distribution is a weighted average. Okay? No matter how we calculated it, we still get the same result. If we take a look at defining the requirements here, we'll see on defining the requirements, it should take us 10 days. The duration or expected time is 10 days, just like we said here. My early start is 0 here. My early finish for this is 10. My late start is 0. My late finish, 10. Slack is 0. So each of these numbers match the row that I have selected here. We can take a look at another one. Let's look at building and testing the hardware. For building and testing the hardware, we see that our duration is 50. The early start is 35, just like we selected here. The early finish is 85. The late start, 35. Late finish, 85. And the slack is 0. The numbers in the selected column here, or selected row here, match our node on the network diagram. Let's take a look at one that's not on the critical path, right? So let's take a look at the developing the patent request. That's the hammock activity that hangs below. We can see that we have the correct ID number, 70, developing the patent request. When we come over, we say that this should take us approximately 15 days, right? Okay, approximately 15 days. Turns out that that's what we have here is 15 days for the duration. Our early start was 10, early finish 25, so on and so forth. So everything is as planned. So now that we have these numbers in, we can now get rid of or put aside our network diagram. Okay. And I will make this full screen so that you can see what we've done. The idea behind what we have created is that we put each of these numbers in and it tells us what our Gantt chart is. You will also notice that our red nodes indicate the critical path. So each of these, defining the requirements, designing the hardware, building and testing the hardware, all of these are on the critical path. They all have a slack of 0, right? Developing the patent request, you can see that we have some flexibility built in. So the flexible part here indicates the total amount of slack that we have, right? So we have, in this regard, quite a bit of slack. We don't have to get started on that nearly as fast. Notice that on the critical path, there is no slack. There is no flexibility. We have to get that done. In addition to that, here's our common start and stop nodes so that we know what day we're going to finish on. Okay? And at the top, it also tells us that our days to completion is 100, which is what we calculated in the network diagram. So if we put in today's date, which as of this recording is 3/25/2020, it tells us that we're not going to get finished with this project until sometime in August. Now, the reason for that is because the project, the Gantt chart actually looks at the holidays that we put in. So it turns out that New Year's Day, Christmas, these two are non-working days, all right? We'll leave it as it is because I want to make sure that we understand that we can't always push people to the limit. And while it's important for us to be able to get the project done on time, we also have to balance the needs of the individuals working on the project with the need for project completion. Now, one of the things you can do is take a look and say, all right, well, I've got extra personnel that I can put. So you look on your Slack and you say, okay, the first place I have slack is in assigning my team. Now, assigning the team should probably not take you that long. It shouldn't take you 5 days to do that. So if we reduce the duration of that, let's say down to 3 days, we shave 2 days off, right? You'll notice, okay, well, nothing changed. The days to completion stays exactly the same because it's not upon the critical path, all right? If we look at one that is on the critical path, like defining the requirements, if we shave time off here, let's say we are able to get 2 days extra here or crash that project by 2 days, we now see that our days to completion changed at the top. So we want to take a look at where we can best put or allocate extra resources. In this particular case, building and testing hardware is probably the most likely candidate. So we're going to take some of the folks from other areas where we have slack, and we're going to put them into the building and testing hardware. So once the designing the hardware is done, we can reallocate people. We can take some of the folks who have assigned the team and reallocate them. The biggest one is developing the patent request, but those are all lawyers, so that's probably not going to be. Testing the software, maybe we could take some of those people. And so we're going to take 5 days from here, and we're going to put it into building and testing the hardware. And so that's going to shave that off by about 5 days. And we're going to say 45 days here, but that then means that this is going to take us 40 days. And we can see that even though this one was shaved and we took the people from here and put them there, it did not have an effect on how long it would take us to test the software. And that's because we had extra slack built in at the end here. And so all we've done is take the slack that was at 10. Let me undo both of those actions. You can see that we had 15 days of slack. And so we took the testing the software, put them here, right? So we can take up to 15 days and put that here and it won't matter. So let's say, for instance, we took the building and testing hardware and we put that at 40 days. and we put this at 45 days, right? And now you can see that testing the software is on the critical path. So let's put everything back to where it was. And at the end, you should have a Gantt chart that looks something like this. Now, what you'll do with this is you will take each of these pieces, leave this part alone, and take each of these pieces, and you will put in your individual piece of your project. So for instance, if you're building a website, the first thing you want to do is define the requirements and then assign the team. But then it might be gathering photos, writing copy, so on and so forth, and each of those would be different. Your duration for this is going to be different because if you wait until August to turn this project in, you're probably going to fail the class. So we don't want that to happen. So if you have any questions, feel free to reach out to me. We'll go over this in class as well, and I'll show you how to make this happen.